Let's review for the Chapter 8 test. First, we're going to simplify expressions. Simplifying fractions, we're just reducing. I think the variables are the easier part. You can knock out 4 of those v's, which would leave you with 1 on the bottom. Then after that, you've got to reduce your fraction. 27 and 81. I know both of those are divisible by 9. If I divide by 9, that's still reducible. I can divide both those by 3. That's 1/3. So pay attention to what's on the top and what's on the bottom. All that remains on the top is 1, on the bottom 3v. Simplify each expression. Done. Reduce your fractions. So let's just do them all. I'm going to knock out one of the x's. I'm left with an x on the bottom. Both of those numbers are divisible by 7. Divide by 7, you get 6. Divide by 7, you get 8. Okay, I can reduce that as well. Both those numbers are divisible by 2. Divide by 2, you get 3. Divide by 2, you get 4. This is going to be 3/4x. We're still reducing fractions, but now we're going to have to factor. You need to recognize the difference of squares pattern. M plus 5, M minus 5. You have to factor because you can only cancel things that are multiplied. On the bottom, I see a GCF of 8. Take out 8, you've got M minus 5. Now that it's factored, it's pretty easy to see how this is going to cancel. Cancel the M minus 5. We're left with M plus 5/8. Next one, I see another difference of squares pattern. X plus 1, X minus 1. Square root of 1 is 1. I've got a GCF of 8x on the bottom. That's going to be 8x times x plus 1. Looks like an x plus 1 cancels and nothing else. I've got x minus 1/8x. Still canceling. Now we're multiplying though, but it's basically the same thing. Cancel stuff on the top with stuff on the bottom. Factor first though. On the top, I've got an easy trinomial pattern. I need 2 numbers to multiply to 12. And are going to add up to that -4. They multiply to -12. That tells me one of my numbers is negative. And then they're going to add up to -4. I've got x plus 2 and x minus 6. Okay, so I can cancel out this x minus 6 with either one of the x minus 6. X minus 6 is on the bottom, but just one of them. You're still going to have one of them. So again, pay attention to what's on the top. What's on the top is 1 times x plus 2, which is just x plus 2. And what's on the bottom is that other x minus 6. Over here, I've got another easy trinomial. 2 numbers are multiplied to 35 and add up to -12. You've got -5 and -7. On the bottom here is another easy trinomial. Looks like -7 and +2. Start knocking things out. I can cancel out this r plus 2 with this r plus 2, r minus 7 with this r minus 7. Nothing else. I've got r minus 5 on the top and r minus 9 on the bottom. Next is division, and I know people struggle with division because they forget the first step. All right, when we divide fractions, which is what we're doing, we multiply by the reciprocal. So you want to just kind of multiply by the reciprocal. Think about it that way. All right, we are multiplying by the reciprocal, and then we'll do the exact same thing as what we were doing. I need to factor. I see an easy trinomial. 2 numbers multiply to 42. Okay, so 42. Multiply to -42 and add up to -1. That's going to be 6 and -7. So x plus 6, x minus 7. Sometimes you can use what exists on the other side of the fraction as a clue because you're assuming you're going to cancel something out. So I can cancel out this x plus 6. I can cancel out x minus 7. All that's left is a 9 on the top. So you could say 9/1 if you want, but the best answer, reduce that fraction, is 9. Next one. Again, we are multiplying by the reciprocal. In division problem, you're going to multiply by the reciprocal. So you can just kind of multiply and flip it, but then we're going to have to cancel some stuff. Look at I see a GCF on the top of 6x, and that's x plus 10. And then I can cancel out 4x squared with 4x squared, and I can cancel out 6x with 6x. All that's left is x plus 10 on the top. You could say x plus 10 over 1, I guess, but it's just x plus 10. Now we're adding and subtracting fractions. This one's different. When you add and subtract fractions, you need a common denominator. Notice I did not need a common denominator on any of these problems before. When I'm adding fractions, I do. All right? So we're just trying to make it fair. And so when you add fractions, it's all about making it fair. I look at this denominator with a 3, and I say, well, this one over here wants a 3. Okay? And this fraction over here has a 2 on the bottom, so and an x cubed. So this one over here needs a 2 and an x cubed. Now it's fair. Now both of them have a denominator of 6x cubed. So just kind of clean up what you've got. Up here on the top left, you've got 2 times 5 is 10, and then x to the 4th. That's going to be 10, x to the 4th. And over here, 5 times 3 is 15. That's your numerator. And all of that is now over 6x cubed. Okay. Can we reduce anything there? I don't see anything that reduces. All right. So I look at the next one, and the next one, the left side needs a v plus 5. And the right side needs a 4. Now it's fair. So distributive property here is going to give me 3v plus 15. Distributive property here, okay, you got to pay attention to this minus. I think this is kind of tricky. So maybe I should have written this 4 over here, because we were distributing the 4, but we're also distributing the minus. Okay, you got to be really, really careful about that. A lot of times people will miss that minus sign, because that's going to be minus 4v, and minus 4 times minus 2 is plus 8 when we distribute. So collect your like terms up there on the top. 3v minus 4v is negative v. 15 plus 8 is positive 23. On the bottom, you've got a 4 and a v plus 5. Now we're graphing, all right? And I think, you know, it helps to understand that there are going to be asymptotes here. When you graph these, and specifically when you have a variable on the bottom, there's probably going to be an asymptote somewhere, horizontal, vertical, oblique, maybe. So what do we do? Well, in this first one, it's pretty easy to see a couple of things. First of all, I like to look at this bottom and say, I know that x cannot equal positive 2. If x equaled positive 2, then we'd have a 0 on the bottom of a fraction. That's going to make my calculator explode in flames and smoke. Okay, that's going to be an error. So I know there is a vertical asymptote showing that x does not equal 2. So I'm going to go right here, vertical asymptote at x equal 2. And your graph better not hit that. All right, don't cross that vertical asymptote with your graph. It's a boundary. And so in this problem, I also know that that's going to be a horizontal asymptote. There is a horizontal asymptote at x equal 1. And so we can draw that right here, horizontal asymptote at x equal 1. Those are the boundary lines for my curve. And a lot of the times it looks like a double boomerang or something. But how we figure that out, we can always just start plugging stuff in. So just don't plug in 2. You're not allowed to plug in 2. 0 is almost always going to be an easy number to plug in. If you plug in 0, 2 over 0 minus 2 plus 1. That's 2 over negative 2. 2 over negative 2 plus 1. That's negative 1 plus 1. That's 0. So I know that I have the point 0, 0. 0, 0 is right here. If you think about symmetry, you can go over 2 and up 1 to the middle of the asymptotes. So you go over 2 and up 1, there's going to be a symmetric point right there. On a multiple choice test, this might be enough to know the answer. All right. Otherwise, let's do another point. So maybe we do like positive 1. If I plug in 1, then 2 over 1 minus 2 plus 1. That's 2 over negative 1 plus 1, or negative 2 plus 1 is negative 1. Got the point. 1 comma negative 1. So 1 comma negative 1 puts me right here. Think about getting to the middle. Over 1 and up 2. So over 1 and up 2, you're going to look like that. That's probably going to be enough for you to know what this graph looks like. Do not cross these boundaries. Draw your curve. It should approach these boundaries. It should not look like this, all right? Because you're using those boundaries as guides. And you have to try really hard to be vertical up here and horizontal over here. That's a pretty good looking graph right there with my asymptotes. So the next one's going to be harder because you're going to have to factor. It's a lot harder to see where the bottom equals 0 until you factor. So let's do that first. On the top is an easy trinomial, x minus 3 and x minus 4. On the bottom, I see a GCF of 2, so let's start with that. GCF of 2, that's x squared minus 3x minus 4. But now I also have an easy trinomial. So you've got this 2, and you've got an x minus 4 and an x plus 1. Now, we've got two different numbers that cause problems. Positive 4 and negative 1 both cause problems. But remember, and we learned this, when the bottom equals 0, it's either a vertical asymptote or a hole. All right, when the bottom equals 0 and it cancels out, that's where it is a hole. So in this case, since that x minus 4 is going to cancel out, and your new fraction would be x minus 3 over 2 times x plus 1, the one that canceled out is going to be a hole. So we are going to have a vertical asymptote at x equal negative 1, and we are going to have a hole at positive 4 comma something. Positive 4 comma whatever we get when we plug in 4. So if I plug in 4, I'm going to have 4 minus 3 is 1 over 2 times 5. That's 1/10. So I'm going to have a hole at 4 comma 1/10. 4 comma 1/10 is about right there. I can draw that hole. It's not going to be perfect, just good enough. All right. Now, as for the horizontal asymptote, remember the horizontal asymptote has to do with the degree of the polynomial. And so you're looking at this degree 2 and this degree 2. So when the degree of the top equals the degree of the bottom, that's where we have to say we're going to divide the leading coefficient by the leading coefficient. There's going to be a horizontal asymptote at y equals 1/2. So y equals 1/2 is right here. Look like that. Now you might be able to guess what this thing's going to look like because of where that hole is positioned. Otherwise, if you don't know what it looks like, make a table and plug something in. Now you could plug into the original function, or I think it would be easier to plug into the reduced function. But I'm going to plug in, something that I can handle, something fairly easy like 0. So if I plug in 0, 0 minus 3 over 2 times 0 plus 1. That's going to be negative 3 over 2 times 1. So negative 3 halves. That's negative 1.5. 0 comma negative 1.5. 0 comma negative 1.5 is right there. So get to the middle, you go left 1 and up 2. You go left 1 and up 2, you're going to be right there. That's a symmetric point. So maybe we try positive 1 and plug that in. 1 minus 3 over 2 times 1 plus 1. That's going to be negative 2 over 2 times 2 is 4. Negative 2/4, that's negative 1/2 or negative 0.5. 1 comma negative 0.5 is right there. You could go over 2 and up 1, over 2 and up 1 puts me right there for symmetry. That's a pretty good looking line, or pretty good looking idea of what I've got. It's going to be vertical, hit those dots, go through that hole, and then end up pretty much flat. So flat, hit the dots, vertical, there's my graph. I think that's probably the hardest part of the chapter, is being able to graph that and give me the asymptotes in the holes. Now, solving equations. We're adding fractions again. So adding fractions, we've got to have a common denominator. Anytime you add fractions, you need a common denominator. That's about making this thing fair. So in order to make this thing fair, the one in the middle wants an n, and the one on the right wants a 2. Now they all have 4n. Now it's fair. So mathematically, what happens is you can multiply both sides by that common denominator, and that's just going to cancel out. And so if you do that, essentially we just have to look at the numerator now. 1 plus 3n equals 1 times 2 is 2. Subtract 1, 3n equals 1, divide by 3, n equals 1/3. Now notice it says, remember to check for extraneous solutions. Sometimes your answer isn't going to work. And so what you have to do, what that involves, is looking at the bottom of this fraction and saying, what makes 0 on the bottom of a fraction? N, in this case, cannot equal 0, for if it did, you'd have 0 on the bottom of a fraction. This does not come into play with 1/3. 1/3 is going to be fine. I can plug in 1/3. It will not give me that mistake. All right, so you look at number 14. 14, this one wants another x. Now they all have x squared. Multiply by x squared, that drops out. I'm looking at 5 plus 6x equals 1. Subtract 5. 6x equals negative 4, divide by 6. And x equals, reduce that fraction, negative 2/3. X cannot equal 0. Okay, great, it doesn't. 15. Before I can see what makes this fair, I need to factor. There's a lot of factoring in this chapter. This has a GCF of p. Take out p, you've got p minus 2. Same thing here. Take out p, you've got p minus 2. That makes it a little bit easier to see what's fair. This one over here wants a p. Now it's fair. Now we can knock out those. Okay, so we look at the top, and we've got 4p minus 3 equals 1. I'm going to add this 3. 4p equals 4. Divide by 4. P equals 1. Make sure to check your answer. I look up here and I see that p cannot equal 0, and p also cannot equal 2. If your answer was either 0 or 2, you'd have to mark it off and say, no, that doesn't work. But p equals 1 is fine. P equals 1 works. Next problem looks very similar. I've got a GCF of v. Take that out, it's v plus 1. V, take that out, v plus 1. So once you see that, you can say, well, the one in the middle wants a v. And now we're rolling. Okay, so the bottom cancels itself out. 4 equals v plus 1. Subtract that over. V equals 3. Is 3 allowed to be an answer? Well, v can't equal 0, and v can't equal negative 1, so v equals 3 is fine. Last problem set, we talk about variation. So you got to know those formulas. This one is a direct variation. So first step for me is write down the formula. Direct variation looks like that. Y varies directly as X. Next step, I'm going to plug in those numbers that they give me. So I'm trying to find that K value. If X is 15 when Y equals 3, so sometimes you can do that in your head. This one's a little bit harder because it's going to give me a fraction. Divide by 15, that reduces to 1/5. K equals 1/5. That's my constant of variation. So I go back to the formula and plug in that constant of variation. Y equals 1/5 X. And then my last step is just do what it says to do. Find X when Y equals 4. So if Y equals 4, I want to know X. Sometimes that's pretty easy to do in your head, maybe not this time. I'm going to multiply by 5 on both sides to cancel out that fraction, and ISO the variable X equals 20. That's direct variation. The next one says inversely. Okay, so that formula looks like this. Inversely is a division. Y equals K over X. So second step, plug in those numbers to find the K value. Y equals 4 when X equals 10. We can multiply both sides by 10 to find that K equals 40. That is my constant of variation. So come over here and rewrite the formula with that constant of variation in there. Y equals 40 over X. And then my last move, do what it says. Find Y when X equals 8. So find Y when X equals 8. That's 5. Y equals 5. These bottom two are kind of tricky. So jointly means there's more than one multiplication. Y equals KXZ. That's jointly. Jointly means it's direct for more than one variable. So Y equals KXZ. Now I'm going to plug in the numbers. If Y is 18 when X is 3 and Z is 2, that says 18 equals K times 6. You can probably do that in your head. K is going to be 3. Forget about the algebra if you don't need it. Divide by 6, you're going to get K equals 3. K equals 3. That is my constant of variation. So I come back to the formula and put that 3 in place. Y equals 3XZ. And then I will do what it says. Find Y when X equals 5 and Z equals 4. Find Y when X equals 5 and Z equals 4. That's 20 times 3 is 60. Y equals 60. All right, last one is the trickiest one. I'm not sure we've seen one worded quite like this. It says Y varies directly as Z and inversely as X. So direct variation with Z and inverse variation with X. All right, direct means times, inverse means divide. And so that's what the formula is going to look like. We solve the problem in the same way. Second time through, we're going to plug in all those numbers. So if Y equals 16, when Z equals 2, that's a 2, and X equals 42. Okay. So, these numbers are kind of big. Might need a calculator for that one. We are going to multiply both sides by 42. So 16 times 42 is 672. 672 equals K times 2. So we'll divide by 2. 672 divided by 2. 336. K equals 336. That's your constant of variation. So we go back to the formula. Y equals 336Z over X. And we plug in those last numbers. Find Y when X equals 8 and Z equals 12. So make sure you plug them in the right place. Y equals 336 336, z is 12, and x is 8. So I'm pulling that calculator back out for this one. 336 times 12 divided by 8 is 504. Y equals 504.